How's it going? Alex here. Quick fun video. Well, I hope it's fun. It was fun for me. But I promised you all like a teaser board video a little while ago when I was having all kinds of like shipping problems and lost shipments and then health errors and everything got pushed back. And I didn't get around to doing that because I'm just so packed with other things. But today, 11/11, Aliexpress is having their big 11/11, like once a year, lowest prices of the year sale thing. So I thought I would take this opportunity to put out a quickie about one of these boards and kind of double dip in that this is something that a lot of people keep bugging me about. So I thought I would go ahead and try to roll the two into one, even for a quickie video, trying to economize time here. So I don't have time to do a full review and test all the different parameters and breakdowns and modes of operation and that type of thing. So I was like, well, what can I do that'll be fun? And I'm like, well, why don't I just do like a benchy off? So this is just taking the stock Creality Melzy board. I think the one in my printer is the 1.1.4 version. And then the revised version of the SKR Mini E3 1.2 edition. And then just use like the stock Creality settings and the stock settings on that board, race them against each other and see what the results are. So if you were just curious to see that kind of thing, cool, here you go. And I'll put a link in the video description to the official store with these boards, so hopefully that's the most recent. Not that I want to send you there specifically for this, but a lot of people are buying a bunch of stuff from overseas during this event anyway. Now, like I said, this is not a review, this is more of like a surface level thing, so that's a fun video. Just pretend you're a consumer, drop it into the printer, and see what happens. But I did include a lot of like techie nerd stuff about the process, so, you know, that's fun. Now, consequently, I do know that with a lot of these first generation 32-bit boards, there are still problems that they're working out, particularly where the one thing meets the other thing. So like drivers, for instance. I don't have a like an up-to-date Windows machine right now, and I don't have time to get one in, do all the updates, and then rerun all the tests with Windows. So bear in mind that there are issues with like the USB connectivity with not just this board, but a lot of boards that are built off of like the same driver structure. Be warned that don't use tethered printing for now. When I do eventually have time to get into all of the board videos I have to do, I'll talk about like the USB connectivity stuff and the driver nonsense and all that. And it varies from like board to board and family to family and processor to processor, and depending on what you're plugging it into and out of. And it works in, you know, Linux and Mac, but not in Windows. But it will work in Windows if you do this, but that's not official. So if you get the official driver, that works, but then it doesn't work in like Slicer and Cura, but it works fine in Pronterface, or you can plug an Octoprint into it and it works okay. So like driver update problems and underlying operating system snafus don't really discriminate. And even the mature stuff is a pain in the butt. FTDI and fake FTDI clones. But hey, at least it's not like you paid $60 for a game to run on your $3,000 gaming computer only to find out that it's not going to work because of software compatibility issues. You guys suck at writing games. Alrighty, here we go. So let me get some of the warning stuff out of the way first, and then we can get into the fun things. Big Tree Tech in their guide specifically says, hey, look, we spec this around this particular printer. If you go outside those parameters, that's on you. So if you're doing like a board replacement and then planning on modding that into a big crazy machine with other add-ons, you might want to hang on until we do a full video. So the way I'm going to treat this is, hey, I just want to update the main board of my printer and see what happens. But I do a power draw test in this video, so if you were using it within those parameters, then you should be okay. And I will be doing a test on the Ender's power supply very soon. I'll be posting that video. So we should get a better idea from that about what the limitations are. And I'll be dealing with beefier boards as well as other cheap alternatives in the future. So just give me this. Just let me do a fun video for once. But let me address the elephant in the room first, which is the problems they were having with the 5-volt regulator rail. Well, between version 1 and version 1.2, they beefed that up quite a bit, and it seems to be working okay in its intended use case. But I'll torture test it in the future and see what's going on, if nobody beats me to it. So they shortened the output loop a little bit more, changed where the components were a little bit, give it a little bit more breathing room between that and some of the other hot components, and then they doubled the thickness of the copper traces to 2 ounces, as well as increasing the size of the heat dissipation patch on the back of the board. So that's a good thing. Now let's talk about, not necessarily a bad thing, but a weird thing. They swapped the processors. They're both still in the family, but the picture on the right is the original, and that is an STM32 F103 family, and then the RET6 you see underneath that label indicates how much flash and RAM it has. So on the left, that's the version 1.2, and it has the RCT6, which is actually a couple notches down. There's still plenty of room. I mean, there's as much room as an Arduino Mega and a lot of the other 32-bit boards out there, but I was really looking forward to taking advantage of that 512K of space. Oh well. They still have the TMC 2209s on there, but they're running them in parallel now instead of in series as far as the UART connections are concerned. I assume that's so that they could just drop a 2208 on there if they had to, but the problem is that means you had to grab a couple extra pins. So they went with NeoPixel for their RGB as opposed to individual R, G, and B driver elements, which is whatever. I wasn't probably going to use RGB anyway, but I did like just the thought of having those 3 extra MOSFETs on the board in case I wanted to use them for fans or something exciting, but that's getting ahead of ourselves into modifications. That's not what this video is about. Now, it does have firmware installed, and it's fully functional and seems to be up-to-date, at least up-to-date-ish. I mean, Marlin 2's changes every day, so if you want bleeding-edge stuff, you'll have to install it yourself. But luckily, the option for uploading from the SD card is here, so it works very much like the, I think it was the Mbed bootloader that was repurposed for the SmoothieWare stuff. Anyway, it works the same, where you put the firmware file onto the SD card, put that in the computer, it flashes itself, you reboot, and you're good to go. In terms of like the default settings, it seems to match fairly closely the stock Ender setup with their the CR10 Melzy board that they have on there. I'm not positive if the accelerations were capped on the original machine. I guess I should test that. I seem to remember they were, but here you can see the defaults are like 500, for example, for the X and the Y axis, and underneath that, the max acceleration values are much higher. And I showed you that EEPROM dump, so obviously there's communication over like Pronterface for USB and serial. You can get and set like the trinamic settings and all that happy stuff, but USB printing is goofy, and there were some people that were, particularly with Windows, talking about problems with the driver, so just be aware of that and screw tethered printing for now. More info on that nonsense in future videos. Other things, they do have a PID hot end profile on there. I'm not sure how close it is, but at least it's on. I imagine it's the same one as the original. Junction deviation appears to be on, but S-curve acceleration and linear advance are off, and emulated EEPROM is on. There's no EEPROM on the board, but it can use a little bit of your flash as an EEPROM, about like 2K, I think. So that's to be expected, and it seems like they have it set up pretty much just to be a herp-derp drop-in replacement. So I'm just going to try to herp-derp drop it in. So here we go, the battle of the benchies. The parameters are same G-code for both prints before and after upgrading the board. Stock benchy downloaded right fresh from the site. The stock firmware for each board will be used, so what came with the printer and what came on the SKR board. No live tweaking during printing. And near stock Cura profile that obviously will be shared between the prints on the 2 different boards. And in preparation for this video and several others that are coming down the line, I grabbed a thermal array, just a single element, so I didn't grab a thermal camera or anything like that. I wanted just the elements so that I could program my own firmware depending on what I was trying to do. And for this, I made just a simple Arduino sketch and a plotter program using the established C++ libraries. So I will use that along with 3 infrared non-contact thermometers, as well as contact thermometers, i.e. thermistors, as well as a power meter. The power to the printer will be filtered, isolated, and stable in both cases, and of course I'm going to run a camera on it. I'll just be using Cura as the slicer, based on just the standard 0.2mm layer height with some of the tweaks that I like to make for, you know, more of a cosmetic model and to speed things up a little bit. So I'll just leave this on here for a second so you can read through, and we'll talk about stuff. You like stuff, don't you? And to ensure no interruptions, we'll be printing off an SD card. Now, this is the one that they give you with these boards, a really tiny one. I'm going to use the one that came with the Ender, and I'm just going to use that for both, so I can just literally pull it out, put the new board in, push it back in, and use the exact same card and G-code. Now, although the hot end cooling fan makes for a lot of the noise in this machine, because it's a noisy freaking fan. Yeah, I can't freaking wait until we get to the part of the series where I can replace it. I did use a sound pressure level meter on each of the runs just to show you what the difference is. And the actual noise of the kinematics, the steppers, that type of thing, they're louder than the fan, but it's intermittent. So the levels would go up from about like 68 to like 72. They peaked at like 64 or so. But man, it became a moot point because as soon as I plugged that trinamic board in, spoiler alert, it was just ghostly silent except for the fans. So yeah, don't really need numbers to qualify that, but if you never heard what one of these sounds like before you put one of those boards in, here it is stock. But noise aside, we have another problem, and that problem is this benchy's starting to look pretty good. Now I know that's not really a problem, but if you're trying to show, hey, here's a board, here's an upgrade board, these printers already print really nice out of the box. And this is what it ended up looking like on the stock printer with basically stock Cura settings, just a little bit of a tweak here and there. This is real nice. I mean, it's not perfect, but I would be super happy with it. And mind you, this is no mods, no tweaks, no nothing. So at this point in time, I was thinking, yeah, this video sunk because I don't know how much better we're going to do with just the board update and not change any of the software settings. But who knows? Foreshadowing, foreshadowing. And some of the things, like some of these little weird things on the hull and whatnot, end up being slicer settings, which you can tweak out, but as per the parameters of this test, I was going to run the same G-code for both prints, so no tweaking. Let's move on to the board swap. And this isn't a how-to video, but I'll just run through this real quick. The board is held on by 4 bolts that use the exact same Allen wrench. I believe it's 3 millimeters. And basically, you could just do a part-for-part swap on here and move the cables over because it's laid out pretty much, since it's meant to be a replacement, like the original Melzy board on Creality. However, I did notice a few things that annoyed me and I had to change. So first off, they tinned the power wire tips with solder. Never ever do this. Don't ever let me catch you doing that again. So they did that on the power and they did it on the bed. So I just cut both of these tips off and I decided while I was going through all the freaking bother of doing that, I might as well cap them properly. So I whipped out the tips and whipped out the crimp tool, and I've linked this in the video description before, but I'll put an Amazon link back under there for anybody who's interested in grabbing this. Obviously, if you're just doing like one printer, it's probably not worth buying a whole tool in the kit, even though they are pretty cheap. But if you're going to be doing this stuff and you'll use these eventually, it's probably a good idea to go ahead and just buy some. Same goes for the fan connector. They just had that put into the auxiliary power, but I decided to go ahead and put a JST connector on it so I could put it in the always on slot that was on the board, as opposed to the rising cage pin style terminals. We call them Euro terminals over here in the States. I don't know what you call them in Europe. It's called a Royale with cheese because they're on the metric system. Another thing I did was splice in this power meter. I think these are meant for like monitoring solar cells or something like that, but I just put XT60 connectors on that and put it in line with the power supply. And I did monitor the temperature of all these connectors while I was printing to see if it rose above ambient at all. I guess there's no reason to tease that. It didn't. They were fine. And let me talk very quickly, since we have this apart and we're rewiring things, about wire dress. Now, they don't give you a whole lot of room in here and there's not a lot of slack, but ultimately, as best you can, try to keep the different types of wiring separate from each other or crossing at a 45-degree angle as opposed to parallel if they're not shielded. Luckily, we have our DC over here and then we have our sensitive circuits over here. In the middle of them, we have this right here, which are our hot end of our bed, and they're PWM controlled. So you want to make sure you keep that clear of signals that are going into the analog bus over here or use as a sensor, because you're going to get that ragged PWM symbol right here that's going to couple into your inputs, and that's going to have a bunch of noises. You're going to throw off your measurements or trigger your end stop falsely or something like that. So do yourself a favor and just nip that in the bud before it becomes an issue. One thing I did notice when I was screwing this down was that there's a lot of flex on this side of the board, which I don't like, so be careful of that when you're unplugging these wires and plugging them back in. But now that it's all together, we can take the G-code that's on the card, which is just a move test, it's not an actual print, and go ahead and make sure it works. And listen to how much quieter this is. Heck yeah, Trinamic. One of the things I did though was I didn't put the heat sinks on top of these Trinamic drivers. Now, of course, you should do this if you are putting this in your printer, but I wanted to test the thermals of these and see how well they would behave without any heat sinks, because primarily they're going to sink the heat down through the board. The heat sinks do help a bit, but they interfered also with me trying to get exact temperature measurements of the driver packages, so I just left them off. I also, obviously, left the lid off the electronics cover because I wanted to be able to measure in there, so there is no forced air cooling as well, which would make it even more thermally challenging. So I thought it would be interesting to see what the hottest part of the board was and to plot that across the entire print. Anyway, to the print. Now I tried to record this so you could see the power gauge in the back and also see the screen, even though there's a nasty glare there that's making the camera freak out a whole bunch. And then, like I said, the electronics cover is exposed. I'm also going to put that thermal array in there and try to set it up so that it's catching the hottest part of the board. Actually, it'll catch the entire... Well, I'll explain how that works. So the actual sensor was an MLX90621, and that has a thermal array of 64 elements. These libraries were provided, but no instructions on how to use them, and none of this crap actually worked with the board that I was trying to do. But I did eventually figure out from some other sample codes that you instantiate the sensor, set the refresh rate, and then it spits out an array, a 64 element float array. This is all just averaging so that it wouldn't be so twitchy. This is just dumb averaging math. And then this took a while to figure out how to use this plotter because I hadn't really used it before, but you can set up your headers up here, and then when you put them down at the bottom, your variables that you're reading, I'm getting the ambient, the maximum, and the minimum, and then plotting them on an XY Cartesian plane, which ends up looking like this. So I just left this running on my computer monitor. The sensor was tethered through an Arduino to the USB serial port over the USB, and plotted the maximum temperature across the board. So this will take the pixel that's zoomed in on the point that is maximum, give that value so I can plot it on here. I also swept around and verified what those hotspots were and checked out other things with these IR sensors. Now, these don't work particularly well on reflective surfaces, but a lot of the things that we have to measure are matte black, which is very nice. And the sensor array, the IR sensor, and the thermistors ended up all agreeing with each other to within like half a degree or so. So that was three-way confirmation. Very nice. And this is a non-technical video, guys. Just wait until the crazy ones. That temperature data combined with the power consumption data that I'm getting from the inline meter and the video gives you a pretty good picture of what's going on with this printer. As a baseline, ambient temperature was about like 25 C. The highest power draw I had was 265 watts, which was around 11 amps at around 24 volts. The hottest component on the board was the stepper drivers, and the highest reading I got on those was still only like 48.4 C, and that's pretty low. If you remember, like back to the TMC 2100 days, those things got spanking hot, and that was with, you know, heat sinks and fans and all this. These were bare drivers just on the board, and I didn't even have the cooling fan on there, so that's nice. The bed MOSFET also stayed nice and cool. It was only around like 40 C. And the hottest the motors got was 36.8 C, and we're not driving those very hard, so that makes sense. But Alex, how did it print? Oh, it print very nice indeed. Again, still not perfect, but it was actually better than the stock board, which I was half surprised by. But let me show you the small differences here. So let's do a quick visual benchy evaluation. The one on the left is the stock board, and the one on the right is the upgrade board. Now, if we look at the old print on the left, you can see that there's those weird diagonal hatchy kind of salmon skin lines. Those do not appear on the new board. Also, although it's very subtle, there's slightly less bulge on the corners, although these are pretty much identical. It's tough to kind of tell. I tried to shine it in the light so that you can see, but the old printer, it did have more of a segmented nature to the roundness, whereas the new board did not have that. And the old print definitely has a lot more ripple or ghosting or whatever you want to call it around the anchor hole, I guess is what it is, and along the trailing edge here. So Was it better drivers? Was it better math? Was it just plain firmware improvements from Marlin 1 to Marlin 2? Well, who's to say, but there definitely was an improvement there. And access to 32-bit and Marlin 2's more advanced features means that you should be able to tune this in even better. And this is already a freaking good benchy, especially for, like I said, a $200-something printer. And don't forget that the original 8-bit board that comes with it has a lot less programming space and RAM, so there's a lot less you can do in terms of turning on additional features, bed leveling, mesh storage, debugging, and that sort of thing. So there you go. Good night, sweet prince. Sail away, little boats. We've gotten our conclusion. Like I said, I do have a lot more board reviews to come, a lot more tweaking to come, a lot more features to come, and a lot more mods to come. But if you're just looking to spend 30 bucks or so, drop a board into your machine and have access to 32-bit 3D printing, including just better prints off the bat, it's not a bad option. But then again, if you're looking for something beefier or more expandable, or with replaceable drivers or different options like higher current capacity and more drives, then you might want to stay tuned and wait and see what we come up with. But if you're into it and you want to grab it at sale price on Monday, I will put a link to the official Big Tree Tech store in the video description, and you can follow that there. Thanks for checking it out. Hope it was fun. Much more testing and more specific nuts and bolts things coming in the future, so subscribe and ring the bell and all that stupid thing that everybody says. All right, I'm out for now. Till next video, get out there and make something awesome.